Dear friends, I myself, Dr. Bharat Parab, discussing the topic Introduction to Graphs. Now, in this, we will see what are linear graphs. Before studying the linear graphs, we will have some example and see what are linear graphs, their need, and how they can be used. Okay. So, location of point P. Look at this. There is a rectangular paper sheet or some rectangle. Okay, and there is a point P on this. Now go through this comment. If one has to specify the position of point P, this in the given rectangle, okay, as we cannot specify unless we have some measuring device, because we cannot specify because we don't know its distance from this anywhere. Okay, we need some device like scale or some measurement. Okay, so we have improved this system here. We have named this A, B, C, D, the vertices of the rectangle, and position of P is denoted in figure 1 as this x units away from AD. Okay, so we know it is x distance away from AD, but it may lie anywhere on this red line, as the whole red line is at a distance of x units from AD. So still the position of P cannot be determined. Okay, so in next figure we have seen A, B, C, D same. We have again denoted the position of P from AB, that is at a distance of y units from AB. Okay, now the P can be explained as x distance from AD and y distance from AB, which are perpendicular to each other. Okay, so go through this comment. So in figure 1 we cannot point out exact position, but in figure 2 we can, as we have vertical and horizontal distances to specify the location of the point. Okay, so you must have got idea that what we are talking about. We are talking about the position of some point on a rectangular sheet or rectangle. Okay, now we will elaborate on the aspect of location of point. Okay, go to this comment. To locate the exact position of any point on plane surface, some researchers have defined a very effective system called Cartesian system. Okay, so in this Cartesian system, two distances perpendicular to each other are given to specify the position of the point as follows. So if you find this sentence difficult, go through this first. This explained here. Okay, so we have two lines perpendicular to each other. These are the two lines. We call them as axis, perpendicular to each other. Okay, horizontal axis is x-axis. This is horizontal, this is x-axis, and vertical axis is y-axis. Okay, no need to explain it again. Now the position of A, go through this. Position of A is 210. See, it is 2. This you will learn this as we go ahead. These distances should be same on this axis, and this should be same on the y-axis. May be different in x and y, but on y 0 to 1, 1 to 2 must be same, and on x 0 to 1, 1 to 2, and all should be same. Okay, so now position of A is 2 and 10. Okay, so this is 2 and this is 10. B is just see 3 and 6. Okay, and that of C is 5 and 7. That of C is 5, 7. Okay, so in this, here x coordinate is written first and y coordinate is written last. Okay, so to remember this point. Okay, always this is x coordinate, so we write this first. This is 2 and 10, and this is 3 and 6. Okay, now again go through this comment. So I'm again reading that comment. So here x coordinate is written first and y coordinate is written last. So 3 6 is different from 6 3. Okay, 3 6 is 3 6, which is B, and which is 6 3, 6 on this, and this is that green point D. Okay, so we know B is 3 6, but 6 3 is different from 3 6. That is what I'm trying to emphasize on. Okay, so do write x first and y last. Okay, so we move ahead. Now let us solve some examples on this topic. Exercise 1. Plot the following points on graph sheet and verify if they lie on a line. Okay, first one, points are A 40, B 42, C 46, D 42.5. Okay, answer for A. This is a Cartesian system. X-axis, horizontal axis, perpendicular this is y-axis. Then choose some scale, suitable scale, and then mark these points equal in distances 1 2 3 like that. And scale on x-axis may vary from scale on y-axis, but within x-axis that has to be same, and within y-axis this has to be same. Okay, that means see, this is the distance for x-axis, but all these distances are same, and for y-axis if this is 1, then on equal distances it will increase by 1 and 1. That is how you have to draw a Cartesian system. You can take both same, it depends on the scale you need. Okay, now we have drawn this. Now point A 40, so 4 and 0 is y-axis, so that is on the x-axis. This is that point. 4 2, so this is 4 and 2, this is that point B. Okay, 4 6, so C, this is C, 4 6, this is C, and 4 2.5 is 4 and 2.5 will lie somewhere here, this is D. Okay, now we have drawn all these points. If you join this, they will lie on this line. We have to also specify that will verify whether they lie on a line. Yes, they lie. Now second one, B. Again, you can use your rules for drawing Cartesian system. Okay. Now P 1 1 1 1. This is P 1 and 1. Q 2 2. Q is this is 2. This is 2. Okay. R 3 3 3 and 3. Okay, and yes for 4 4 and 4, and if you join them they lie on a single line. Okay, now third one, or C, K is 2 3. See, this is the system. 2 and 3 will lie somewhere here. Okay, this is K, this is given here. L is 5 3, so on x axis is 5 and 3, this is L. M is 5 5, 5 and 5, this is M. Okay, and N is 2 5, so x is 2 and y is 5, so this is 2 5. And if we join, these 4 points, then clearly they are not on a single straight line. Okay, so if you mention that, because we have to verify if they lie on a line, that is the answer. So we go to this comment, plot points of graph A and B lie on a line while that of C are not on a line. Okay, this sentence completes your answer. Okay, so we move ahead. Second exercise, write the coordinates of the vertices of each of these adjoining figure. Okay, This is a Cartesian system given, and there are some points plotted on this. Okay. Answer: coordinates of the points given in above figure are: O is 0, 0, A, A is for x is 2 and y is 0, so 2, 0. B, B is, see, it is 2 and 3, okay, 2, 3. C, C is for x is 0 and y is 3, so 0, 3. P, P is here, so this is 4 and this is 3, so 4 and 3, 4, 3. Q is 6 and 1, 6, 1. R, R is here, so this is 6 and this is 5, 6, 5. Yes, yes is 4 and 7, 4, 7. K, yeah, where is K? K is here. 10 and this is a point. 5. Okay, 10, 5. L, L is 7 and 7. And M is 10 and 8. Okay, so always give X coordinate first. Okay, you must have got this. Okay, so we go ahead. Applications. Let us see where these are applicable and where they are used. Okay, these linear graphs. Let us take an example of a petrol used in a car. The amount of petrol used in liters does not depend on any parameter. That means in a particular journey, if you need some amount of petrol, does not depend on any parameter, means is not talking about the road conditions and make of the car, is talking about the cost of the petrol per liter. Okay, even if you increase the cost, amount you are going to use in particular journey will not change by the cost of the petrol. Okay, that is what it means. But the amount you have to pay of that journey per that journey depends on the petrol used. If you use more petrol, you will need more money. Okay, so with this, just go through this comment. So here amount of petrol used in liters is independent variable, as it does not depend on the petrol price. Okay, but its cost or the amount you have to pay depends on the amount used. If you use more petrol, you have to pay more. Okay, so that is a dependent variable. Read this many times and try to understand this. Okay, still if you face problem, write to me in the comment section and I will again explain you personally. Okay, so go to this comment. Hence, with the relationship of about two variables, a graph can be drawn. Okay, such type of graphs gives better information about dependent variables or unknown variables. Okay, we will see some examples, then this will be clear. So let us study some graphs related to this relation, and we will be dealing with linear graphs only. Okay, so we move ahead, see some examples and try to understand this. Still, if you face any problem, let me know through comment section. Okay, exercise number 3 or third one. Draw a graph for the following. First one, take this table, sides of square in centimeters and perimeter again in centimeters. When side of square is 2, perimeter is 8. When side is 3, perimeter is 12. 3.5, 14. Side of square is 5, 20 and 6, 24. Okay. So answer, let's say a part of question is here. Is it a linear graph? Okay, you have to answer this also. Answer. Then take x-axis, y-axis, and on x-axis take side of square, which is here, and y-axis take perimeter. So when first one, this is x, this is y. So 2, 8. See the scale we have chosen. Okay. This is 2, this is 8 is here. 3, 12. Okay. 3.5 will be here and 14. Okay. For 5 it's 20 and for 6 is 24. When we join all these points, we see that they lie on a line, on a straight line. Okay. So yes, we have to answer this part. Yes, as we get a straight line by joining all the points, it's a linear graph. Okay. So got it? So we go ahead for the second one. And the second one, here sides of square against area. Okay. So the sides are same 2, 3, 4, 5, 6, and area the square is 4, then 9, 16, 25, 36. And again the same question is asked, is it a linear graph? So we'll answer this. Answer is, we are drawing two axes, x-axis, y-axis. Now on x-axis we are taking sides of square and y-axis the area. Okay. So here 2, 4, 3 is 9, 4, 16, 5, 25, 6, 36. See in last and this graph there is this change that we have changed the scale so that here 36 should be within the graph. Okay, we'll learn this as we go ahead. Okay, so now we have drawn this. Okay, so see, if you see all these or join this, you can see that it's not a straight line. So no, it's not a straight line, it's a curved graph, or what we call as it's a parabola. Okay, we will learn about this in higher standards. Okay, such type of graphs are called parabola. Okay, so we go ahead. This is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of graphs, let me know through comment section and I shall solve it. Thanking you. Good luck. Okay.